So this could very well be an exciting video because we start with this idea of a Fourier series, that we could take a periodic function and represent it as an infinite sum of weighted cosines and sines. And we use that idea to say, well, can we find formulas for those coefficients? And we were able to do that using the powers of calculus. And now we can actually apply it for this particular square wave. And I picked a square wave that has a period of 2 pi, and that's where actually a lot of these 2 pi's came out from. And that's also why we started here at cosine t and sine of t. They both have a frequency of 1 over 2 pi, which is the frequency of our original square wave. And then the other terms have frequencies that are multiples of that. If we had a different period, then all of that would change. But I picked this period to just make the math a little bit simpler, and we will generalize in the future. But now let's actually evaluate a sub 0, a sub n, and b sub n for this particular square wave. So the key to realize is that our square wave between 0 and pi, because we're going to keep taking the definite integral from 0 to 2 pi, from 0 to 2 pi, from 0 to 2 pi, the key to realization here is from 0 to pi, our function is equal to 3, and from pi to 2 pi, our function is equal to 0. So all of these definite integrals, so this definite integral, for example, is going to be the same thing as, and I'll do it once, and then we'll see that trend. This is the same thing as 1 over 2 pi times the definite integral from 0 to pi of f of t dt plus the integral from pi to 2 pi of f of t dt. Now, f of t between 0 and pi, we just said it's equal to 3. And f of t between pi and 2 pi, well, it's going to be equal to 0. And that's actually the case for these other situations, that f of t is going to be 0 from pi to 2 pi, and 0 times anything is going to be 0. So the integrals, the definite integrals over this, the second part of the interval, are always going to be 0. And so it boils down to this. And so what's the definite integral from 0 to pi of 3 dt? Well, this is going to be equal to 1 over 2 pi times, so if you evaluate this, the antiderivative of 3 would be 3t evaluated from 0 to pi. And so it would be 3 pi minus 3 times 0, which is just 3 pi. So it's equal to 3 pi over the 2 pi that we had already, over the 2 pi. And so this is going to be equal to 3 halves. 3 halves. And that makes a lot of sense, because a sub 0, we said you could view that as the average value of the function over that interval. And the average value of that function is indeed, if it's 3 half the time and 0 the other half of the time, well, then the average is going to be 1.5, or 3 halves. So that is our a sub 0. So now let's figure out the general a sub n, where n is not equal 0. So a sub n, well, we are just going to take, it's going to be 1 over pi, 1 over pi, the definite integral. I could go from 0 to 2 pi, but instead I'm just going to cut to the chase. I'm going to go just from 0 to pi, because the integral from pi to 2 pi is just going to be 0, because the function is equal to 0. It's going to be 0 times cosine nt is just going to be 0. So for this particular square wave, I can just worry about from 0 to pi. From 0 to pi, f of t is 3. So it's going to be 3 cosine nt. 3, let me do it in that color. 3 cosine of nt, cosine nt dt. Now, what is this going to be equal to? Well, we can do a few things. We could take our 3 and bring it out front. So let me do that. So we could take that 3 and bring it out front. So just putting the 3 out here. So take that 3, put it out front. And we know that the derivative of sine of nt is n cosine of nt. So let's multiply the inside and the out, or let's multiply the inside by n. And then we could also divide by n, but we could put that outside. It'd be n divided by n. We haven't changed the value. And so this is going to be equal to 3 over n pi, that's just what we had out here, times, well, the antiderivative of this business is going to be sine of nt, and we're going to evaluate from 0 to pi. So this is going to be equal to 3 over n pi times sine of n pi, well, that's going to be 0 for any n, minus sine of 0 times n. Well, that's going to be 0 for any n. So all of this is just going to be 0. So a sub n is going to be equal to 0. the coefficient on any, for any of a sub n's for any n not equal 0, it's going to be 0. So actually we're not going to have any of these cosines show up in the Fourier expansion. Well, let's think about our b sub n. When you look at the shape of the square wave, it actually makes a lot of sense. But let's now tackle our b sub n's. So our b sub n's, get a little space here. So b sub n, same thing. We could just worry about the interval from 0 to pi, because from pi to 2 pi, our f of t is going to be equal to 0. So this is going to be equal to 1 over pi times the definite integral. Once again, I'm only going to worry about from 0 to pi dt. Now the value of the function from 0 to pi is 3. We've seen that before. I could put it here, but just to get a little bit simpler, let's just stick it right over here. So it's going to be 3. Actually, I don't want to skip too many steps. It's going to be 3 times sine of nt. 3 sine of nt. And let's see, how can I reconstruct this so it's easy to take the antiderivative? Well, this is going to be, if we take that 3 out front, it's going to be 3 over pi. And then you have your definite integral from 0 to pi of sine of, let me do that same color, sine of nt, sine of nt dt. And we know the derivative of cosine nt is negative n sine of nt. So let's throw a negative n in here. So negative n, but let's also divide by negative n. Just like that. If you have negative n divided by negative n, we haven't changed the value. That's just 1. And so this is going to be equal to negative 3 over n pi times, we're going to take the antiderivative here. So this is going to be cosine of nt evaluated from 0 to pi. And so what is this? This is going to be equal to, this is equal to negative 3 over n pi. Cosine of 0n, that's going to be 1 for any n, minus cosine of, oh sorry, why did I start at 0? It's going to be cosine of n pi, minus cosine of n times 0. So minus cosine of 0. Cosine of 0 is just going to be 1 for any n. And so there you have it. We have a general, and you might say, well, cosine of n pi, is that positive 1 or is that negative 1? Well, it depends. If n is even, this is going to be positive 1. If n is odd, this is going to be negative 1. So it depends. Actually, let's just write that out. So b sub n is equal to, let's write those two cases. So if n is even, and another one if n is odd. So if n is even, you're going to have negative 3 over n pi times, actually let me just do it over here so we have the space. So what would this thing evaluate to if n is even? So this n, if it's even, it would be like cosine of 2 pi, cosine of 4 pi, cosine of 6 pi. Well, in that situation, this is going to evaluate to 1. You're going to have 1 minus 1, which is 0, so the whole thing is going to evaluate to 0. And if n is odd, cosine of pi, cosine of 3 pi, cosine of 5 pi, well, those are going to evaluate to negative 1. Then it's going to be negative 1 if n is odd. Negative 1 minus 1 is negative 2. And so this is all going to be negative 2. Negative 2 times negative 3 over n pi is going to be 6 over n pi. So there you have it. We have been able to figure out our Fourier expansion. It is going to be our square wave, and we definitely deserve a drum roll. This is many videos in the making. F of t is going to be equal to a sub 0, we figured out in this video, is equal to 3 halves. So it's going to be 3 halves. Let me write this. Well, let me just write it all in yellow. So 3 halves. Now, we don't have any a sub n's. We figured that out. All of the a sub n's are going to be 0. And then the only b sub n's we have is when n is odd. When n is odd. So we're going to have b sub 1. So that's going to be 6 over 1 pi. 6 over 1 pi sine of 1 times t. So sine of t. Plus, now we're not going to have a b sub 2. We're going to have a b sub 3. So 6 over 3 pi times sine of 3t. And of course, this is the same thing as 2 over pi times sine of 3t. Plus, now we were not going to have a b sub 4, we're going to have a b sub 5. So that's going to be 6 over 5 pi. Actually, I liked writing it. It's nicer to actually not simplify here because you can see the pattern. So it's going to be plus 6 over 5 pi times sine of 5t. And we're just going to go on and on and on. And there you have it. We have our Fourier expansion. In the next video, we're actually going to visualize this.